So there it was. It's caught a pretty good wave. Should get some good data from that. Oh, here comes the second. Oh, God. Oh, glad it's holding up. Not like we've ever lost it. So this right here is what I use. This is an Arduino and an accelerometer with a bunch of electronic components. And I built this to measure the acceleration and velocity, and finally to find the energy of ocean waves. These are sample plots of my acceleration and velocity that I found. Here's acceleration. Each of these spikes is a wave, and these are the corresponding velocities. I analyzed each of those velocities, put them all in Excel, averaged them out. Then I used a bunch of knowns like density and gravity, made a bunch of assumptions off of the velocity, size, volume, found the height from the surf report of each wave, calculated the mass, calculated potential energy and kinetic energy to find the total energy of each wave that I assumed was hitting my box. I just put that whole Arduino that I showed you earlier in a Tupperware and then attached it to a rope, and then finally I set that equal to what I assumed to be the total or the kinetic energy of the box to find that I could assume that the velocity was around 15 meters per second, where I had what I calculated or what I measured was 12.5 meters per second. So I could tell that my assumptions were pretty good. So this theory of using ocean waves to generate energy is certainly not new. There's been a lot of conceptual ideas, like for example, these are just magnetic coils secured to buoys, and as the wave goes through, the shaft goes through the coil, generating electricity. And this other picture I have here, this is just a bunch of pretty similar, well, not quite the same, but longer wave generating functions or generating machines. And basically what all these do is just use the change in position of the device as it goes up and down with the wave. And all of these are in the sort of the lull waves, were the ones that just kind of go in sinusoidal up and down. Although in my project I looked at the actual crashing part of the wave, which has a lot more energy. On average, it has been calculated that the average amount of power output of each of an average wave that's around 3 meters, a couple miles off the coastline, can generate close to 36 kilowatts of power per meter, and that's pretty good. And that peak power is around 1.7 megajoules per meter. I calculated that there's over 1 million meters of coastline in California alone, and from our previous equation, knowing that there's 36 kilowatts per meter of power in each wave, multiplying that out gives close to 50 gigawatts of power just if we had ocean wave collectors along the entire coast of California. This is showing how to get the flux of the waves to find the power. So the flux is right here, and it was found using just the density and gravity along with the 64 pi constant. Here's the equation I was using before to find the average energy or the average power per meter of the ocean waves. So this is assuming just a few kilometers off the coastline, assuming a wave height of 3 meters and a period of 8 seconds in between each wave, using the already calculated flux of the waves, and we get our 36 kilowatts per meter. So in conclusion, there's still a lot of problems with generating power from ocean waves. Considerably, one, it's really expensive, and we've only just started tapping into this power. Two, it can be seen, if you covered the entire coastline with these, it would be a huge inhibitor to navigation as well as marine life. Number three, it can be really loud, and people don't like that. And lastly, just a lot of people think of it as very ugly, and it takes away from the beauty of the ocean.